Season 5, Motion and Forces, Episode 104, Free Body Diagrams. Welcome, strangers. Okay, so free body diagrams are used to show the forces that are acting on something. Something is singular. Of course. Perfect moment to do hair drying, right? Welcome, strangers. Free body diagrams are used to show the forces that are acting on something. Something as in singular something. One thing. Can you not? Free body diagrams are used to show the forces that are acting on something. Something as in singular something. One thing. If the weight force is bigger than the air resistant force, then the thing is in free fall and accelerating. If a boat is bobbing up and down on the ocean, upthrust is preventing it from sinking, as this is balanced with the weight force, so it overall has an almost net force of 0 in the vertical direction, so not moving much, so it's pretty stable at resting. However, and that's a big however, not exactly. See, the thing is, it is bobbing from the imbalance of forces. Say it was in the boat park, as in, you know, the car park, but for boats. I don't know how to explain it better, but say it was in the boat yard. The boat yard, that sounds better. Say it was in the boat yard. You know, like the place where boats are being constructed or repaired or something. The boats on dry land would have an actual net force of 0. And the reaction force is balanced with the weight force. If thrust is more than water resistance, the boat accelerates forwards. Yeah, so it moves forwards rapidly. It is the resultant forces that lead to acceleration or deceleration. If the net force is 0, then this means that the boat is stationary, as in not moving stationary, not as in pens and papers stationary. I think that has an E instead of an A. Yeah. So, you know, the pens and paper stationary has an E. E-R-Y. And stationary as in stopping stationary, as in not moving, is stationary with the S-T-A-T-I-O-N-A-R-Y. Yeah. So, or, and it's a big or, it is moving at a constant velocity. Remember, velocity is where direction matters, and it's basically speed with direction. Velocity is speed with direction. Constant velocity is, constant speed with direction. It moves at a steady pace, yeah? It's constant pace. The resultant force is the vector summation of forces acting on the object in question. Well, the boat in this scenario. I mean, you know, Imagine interrogating the interrogator. Why did you ask that question? What is your reasoning behind that phrasing? How does that make any sense? Explain! I mean, that would be funny. Imagine doing that whenever someone asked you a question. I bet it would get annoying quite quickly. See you next time at Physics and Necrotic World. This is your host, Rimona Christian. All out.